Hello, welcome to this tutorial. I'm Victor Engström, the creator of Sonity, an audio middleware for Unity. In this tutorial, I'll show you how to set up and use the improved sound physics and the new SoundPhysicsCondition system, which I've added in Sonity 1.0.5. Sound physics is a component which can be used to easily play impact, friction, and exit sounds. We'll also go through how to use intensity to dynamically control the audio. So, let's first take a look at the advanced example scene, where sound physics is used to play impacts and friction sounds. All the example assets and scenes shown in this tutorial are available both in the paid and free version of Sonity, if you want to check them out yourself. In the first basic example, we'll start out with playing metal impacts, using sound physics and making them respond to the velocity of the impact using the intensity parameter. Then in the intermediate example, we'll add friction and OnTrigger sounds for water. For the advanced A example, we'll add SoundPhysicsConditions to play unique impacts per terrain layer. And then lastly, in the advanced B example, I'll show you how to set up SoundTags to play all the previous impacts in a single sound event, giving you more control over how the different sounds are mixed together. Let's start with taking a look at the basic example and see what we have to work with. So, we want to play impact sounds when the box is colliding. First, we'll create the box impact assets. Just select all the audio clips, right-click, create, Sonity, create assets from selection, and then the single sound event option. This creates a sound container per group and adds them all in a single sound event. As you can see, you can use the shortcut Ctrl-Shift-W to create a single sound event and Ctrl-Shift-Q to create multiple sound events. This impact sound has 3 layers: hard, medium, and soft, which we can preview with Ctrl-Q and stop with Ctrl-W. Now let's add a sound physics component. As you can see, sound physics is split up into multiple components. This is because of performance reasons. For this basic example, we don't need friction sounds, so we'll select sound physics no friction. A rigid body and a collider component is required for sound physics to play. Let's add the impact sound. And we want play on to be left on collision. Let's try it out. At the moment, the impacts are playing all at the same volume. We need to set them up to respond to the incoming velocity. So let's just select all the impact sound containers and enable intensity. This makes the sound play at a lower volume when the intensity is at a lower value, and vice versa. Intensity is a sound parameter which is passed when the sound event is played. It contains an intensity float value which can be used to control any of the main settings in the sound container, like volume, pitch, spatial blend, distortion, etc. You can use intensity for anything from controlling a car engine sound with RPM values to crossfading different stems of music. Check out the documentation if you want to learn more on how to play sound events with a sound parameter intensity. Now, let's try it out with the intensity enabled. As you noticed, the volume is basically still constant in all the hits. This is because the incoming velocity is not scaled properly. To fix this, we'll debug intensity in the sound event. Intensity is expecting values ranging from 0 to 1. We need to scale the incoming velocity to the correct range. For this, we'll use intensity record. Now it will record all incoming intensity values, which will be visible here. So let's record some. We can see that it has recorded 7 values, and that 9.7 is the highest value recorded. To scale this to the correct ranges, we'll use scale max to 1. This uses the recorded values to calculate a multiplier, where the max value is scaled to be 1, which is useful for impacts, where the lowest value should be 0 and the highest value is unknown. You can also edit all of these values to make the intensity softer or harder. What's also nice with recording intensity is that you can play your game like normal and save all of the values for later. Let's play the scene again with scaled intensity. It now responds much better to the velocity of the impact. Now, let's set up the velocity crossfades. We have 3 velocity layers: hard, medium, and soft. What we want to do is to crossfade them over intensity, where soft is played at a low velocity, medium at a medium velocity, and hard at the highest velocity. So, let's select all of them and enable intensity crossfade. Then set layers to 3, because we have 3 sounds we want to crossfade. After that, we'll set this is to 3 for hard, 2 for medium, and 1 for soft. With the crossfade function, you can easily create perfect crossfades between as many layers as you'd want. For example, we could have a 5-layer crossfade, or a 10-layer crossfade. Let's reset this to a 3-layer crossfade. There is an automated way to set up crossfades, which I'll show you later. But now, let's try out the crossfades. That's a lot more dynamic sounding than before. We'll record some more intensity values to make it easier to tweak the settings. Let's auto-scale it again. Now I think it's a bit too soft. So we'll increase the multiplier a bit. And increase the roll-off to focus the intensity values in the higher ranges. We can also enable threshold. If the intensity value is below the threshold, the sound won't be played, which is illustrated by the white color as you can see here. Threshold is good for performance, because it skips playing quiet, low-intensity sounds. Let's try it out again. I think we could make the impact even better and more dynamic. Let's try changing the pitch with the intensity. With the default values, the sound is pitched down at low intensity and up at high intensity. That's a bit too much effect. Let's lower it to ±2. That's better. Now, let's add some low-pass filter. This will make it more muffled at lower intensities. That's too much filtering. Let's lower the amount a bit. If you want to test intensity in the editor in a more controlled fashion, you can use the preview intensity slider here. And we can change the intensity while previewing the sound with Control Q. Now we have learned how to play impacts with SoundPhysics and how to set up and work with intensity. Now for the intermediate example, we're going to add friction and OnTrigger to play water sounds. Let's take a look at the example scene. So here we'd want to add some impact sounds, friction sounds, also some water sounds, both when it's impacting and sliding on the different materials. So we're going to start with creating the assets for the new sounds. Just select the metal box friction sounds and create multiple sound containers and a single sound event with Ctrl-Shift-W. We'll create multiple sound events with Ctrl-Shift-Q and a single one with Ctrl-Shift-W. We have an exit sound which we want to play when the box is exiting the water. A friction loop which we want to play when the box is moving in the water. And a water impact sound which we want to play when the box impacts the water. Now let's enable intensity, so we get lower volumes at lower velocities. We'll start with water impact and exit. Because they only have one velocity layer, they don't need crossfades. We also want the friction sound to react to velocity. Both the metal and water friction have two velocity layers. Metal friction hard, soft, water hard, and soft. And this time we'll use the automatic crossfades instead of setting it up manually. It automatically sets up intensity or distance crossfades based on the names of your assets. So if the group of sound containers are named hard, medium and soft, it will automatically turn them into a 3-layer intensity crossfade. If they are named hard and soft, it will create a 2-layer intensity crossfade. This also works with multiple groups of objects. So, you can select all the sound containers in your project and let automatic crossfades set them up for you. You can read more about this in the tooltip and documentation. Let's just select all the sound containers and then press the automatic crossfades button. And because the groups were named hard and soft, it automatically set up a 2-layer velocity crossfade. Now let's add the SoundPhysics component. This time we want to play friction sounds, so we'll use the normal SoundPhysics component. Let's start with the metal impact. And leave it on collision. Then we'll add the water impact and change the play on mode to OnTrigger. This makes it play when the collider touches the water, because it's set to isTrigger. Then we want to enable friction. Friction plays when the SoundPhysics object is continuously touching a collider. Now add the metal box friction and leave it at on collision. Then the water friction, which will change to OnTrigger. Finally, the exit water sound. And we'll change that to OnTrigger as well. Before playing, let's enable intensity record on all the sound events. And let's try it out. As we see, we have a lot of recorded values. Let's start with scaling them, so max is 1. We have values in metal friction, metal impact, water exit, water friction, and impact. As you can see, the water friction sound is still playing, because the box is bobbing around slowly in the water. We can solve this by enabling threshold. Now the sound won't play when the velocity is too low. Let's try it again. We can also see that most of the recorded values are very low. So, to make it sound more high intensity, let's increase the roll-off. That's better. Now we'll add some fade in and fade out to the friction loops to make it sound a bit smoother. Let's start with 0.2 seconds. And we'll try it out. Though I think we can spice it up a bit more. Let's add some intensity pitch on all the new sounds. And add some low-pass filter to the friction sound to make them a bit more dynamic. Now let's try it out again. Now we've learned how to add friction sounds and use OnTrigger in SoundPhysics. In the Advanced A example, I'll show you how to use SoundPhysicsConditions to play unique sounds for different surface types. The SoundPhysics component is set up like last time with metal and water sounds. We want to play dirt and grass impact sounds when the box hits the brown and green terrain material. As we can see in the terrain here, we have two terrain layers. Index 0 is named grass, and index 1 is named dirt. We'll use these terrain layer names as a condition for playing the grass and dirt sounds. Let us start with creating the assets. And we want to create multiple sound events. Now we have dirt and grass impact sounds. Let's add them to the SoundPhysics. So we'll add dirt, change it to on collision. We also want to enable conditions. And then we add the grass, which should also be on collision. Now we need SoundPhysics conditions. Let's create some. Right-click, create, Sonity, and then SoundPhysics condition. We'll name it surface dirt. Conditions are used for easily setting up and managing advanced settings for when a sound should or shouldn't be played. As you can see here, we have many conditions which we can add to determine if a sound should play or not. We can for example use isTag, which checks the colliding game object's tag. So now it will only play if the colliding game object has the untagged tag. Then there's layer, which is the same but for game object layers. Has component checks if the colliding object has the specified component. Terrain name checks if the name of the most dominant terrain layer contains the assigned string. Terrain index is almost the same, but it checks the terrain layer index instead of the name. If I go back to isTag, you can see we have an option called abort all or no match. For example, if I enable isLayer, now if either the untagged tag or the default layer matches, it will play. But if I enable abort all or no match for isTag, now if the tag isn't matched, it won't play, even if the other condition matches. You can also use isNot. Now the sound will play if the condition isn't matched. The isNot types also have a similar abort all on match setting. If enabled, the sound won't play if it matches the isNot condition, regardless if there are any other positive matches. Now let's get back to setting up the conditions to play when it impacts the dirt terrain layer. First, let's change play on to on collision, then enable terrain name and change it to dirt. The name you write here is not case sensitive. More information is available in the tooltips and documentation. Now let's duplicate the condition and change the terrain name to grass. Also, as a side note, we could have used the terrain layer indexes instead of the names. But I find the name easier to manage because you can have multiple terrain layers containing the same name. Now we can just add the SoundPhysics conditions. So we'll add dirt and grass. We want to enable intensity record for the new impacts. First, let's scale the intensity of the recorded values. And also lower the volume. Now we've learned how to set up and use SoundPhysicsConditions to play different impacts per surface material. For this last Advanced B example, I'll show you how to set up SoundTags to play all the previous impact sounds in a single sound event. With this setup we can easily mix the metal impact sound with all the different surface types. As we continue from the previous part, we have metal, water, dirt, and grass impact sounds, which at the moment are all played separately. We can make it sound even better if we combine them so that, for example, when the water is hit, metal is also played with a lower volume. To get this kind of control over the sound, we'll use SoundTags. They will be used to play and mix between multiple sounds in a single sound event. We'll start with removing all the old impacts. Then we'll duplicate the metal box sound event. Now let's create the SoundTag object. Right-click, create, Sonity, and SoundTag. Grass, dirt, and water. SoundTags are just empty helper objects, which are passed as a reference, making it easy to manage many objects and allowing you to rename the SoundTag without breaking any references. Now we can add them to the metal box sound event. So go down here, enable SoundTag, and make sure local SoundTag is selected. For usage of the global SoundTag, take a look at the Sonity tutorial video called Realistic Gun Sounds. Let's add some more slots, and now assign the SoundTags: dirt, grass, and water. And then the sound events: dirt, grass, and water. If you play the sound event with a sound tag and it matches the sound tag here, it will play any sound event you've added. Any modifier set to either the base or sound tag sound event will also be applied. As a side note, you don't have to have any sound containers in the base sound event. You could just have sound events in the sound tag. Now let's preview the added sounds together with the bass sound. As you can hear, the bass metal impact is a bit too loud. Let's add a bass volume modifier. Let's lower the volume a bit. And without the bass. And with the bass again. We want just a touch of the metal impact. Let's also lower the intensity a bit as well. This multiplies the intensity value, which helps make the sound a bit softer. We can also affect how the SoundTag sound event is played. Let's try pitching it up. And lowering the volume a bit. Now let's do the same thing for grass. Add a volume modifier to the bass sound. And lower the volume a bit. Maybe slightly more. Let's also add an intensity multiplier, but this time we'll make it even softer. I think it could do with some pitching as well. And lowering of the volume. For the water sound, we want an even softer metal impact. So let's lower the volume. And also lower the intensity. Now we just get a hint of the bass sound. The next step is to set up the SoundPhysics conditions. Let's duplicate an old condition and use it for water. And just reset the settings. Because this is water, we want play on to be OnTrigger. We also need to add a condition for the water. All the water objects are assigned to the water layer. So let's enable isLayer and change that to water. And now add the SoundTags. Dirt, grass, and water. When these conditions are matched, they will play the sound event with the SoundTag we just added. So the dirt condition will send the dirt SoundTag, etc. Now, to combine all of these subconditions, we'll create a group. Just reset the settings and add all the surface conditions as child objects. So now we only have to add one SoundPhysics condition to our SoundPhysics component, which also makes it a lot easier to manage a large number of conditions. Let's add the sound event to the SoundPhysics. And add the condition. We need to change this to play on both on collision and on trigger. So now both the solid collisions and the water impacts will play. Let's try it out. So, all the conditions we had set up played, but the problem is that the basic impact doesn't have a condition. What we want to do is to play the basic sound without a sound tag when no other conditions are met. For this, we can enable play disregarding conditions in the group SoundPhysicsCondition. This makes it always trigger the condition, but it still checks for all the child conditions for any sound tags which are triggered. Also, we only want this for collisions, so let's change it to on collision. And let's try it again. There we go. Now I'll quickly go through and explain how the whole sound tag chain works again. So, first the SoundPhysics component is triggered by an impact. Play on is set to on collision and trigger, so both the collisions and trigger boxes are going to play sounds. Then we have enabled conditions. Therefore it will evaluate the selected SoundPhysics condition. It starts by evaluating the parent condition, which is set to play without a sound tag, on collision, disregarding any conditions. So if the impact is a collision and it doesn't match any of the child conditions, the sound will play without a sound tag. Then it will evaluate the child conditions. So first it checks play on, which is set to on collision. Then it checks if it has impacted a terrain layer and if that terrain layer contains the name dirt. Let's say it impacts the grass terrain layer. So dirt won't return a match and it will continue checking the next child condition. Next it checks the grass condition. Play on is set to on collision and terrain name will return true because the grass terrain layer contains the string grass. The grass condition has the grass sound tag assigned. So now, when it returns true, the sound tag is going back to the SoundPhysics component. And the SoundPhysics will play the sound event with that sound tag. First it plays the bass metal impact sound. Then, because SoundTags is set to local, and it matches the grass sound tag, it will play the grass impact with these sound tag modifiers, and also apply the bass modifiers to the metal impact sound. Now, let's compare it to the old scene without sound tags. And again, the one with the sound tags. The sound tag version sounds more refined because the metal sound is reused in all the different collisions, with a custom mix of the different impacts. Now we've learned how to set up and work with sound tags, to play and mix multiple sounds in a single sound event using SoundPhysics condition groups. So that's all for this tutorial. At the website sonity.org you can find links to more tutorials and some really good documentation. If you have any questions, join the support Discord.